doing logarithmic equations. So the first one, remember how I said ln is just log to the base e? You've seen it before, right? So if I want you to solve something like this, 2 ln x equals ln of 5 plus 4x. I want to solve that. Now, I know you haven't done it before, but tell me about that 2 out the front, what I can do with it. What can I do with that 2 out the front? 2 times the log. I can make it the power. Remember that rule? So that is the same as writing ln of x squared equals ln of 5 plus 4x. Now, the log of that equals the log of that. So ignoring the logs now, what must equal what? That's right. So I just now solve x squared is 5 plus 4x. Now we've done all the manipulating with log functions. We only just never solved them. So all it is manipulate it so that they both look like log of this equals log of that. And then you compare them side by side and you say, well, the x squared has to equal that. Do you know what to do now? X squared quadratic. Take everything over to the left. Minus 4x minus 5 equals 0. How do you solve that? You factorize it. Keep going. What two numbers? Multiply to give 5, but add up to give -4. Well, it's got to be 5 and 1. -5, +1. Oh, right, wait a sec. Now, x is 5 or x is -1. But, no, that's allowed. All good. So what you want to then do is just check. You know how your... No. Actually, I really shouldn't be doing these yet. I'll tell you why. That's the log curve. I need to continue these next lesson. Girls, you haven't done log curves. Well, you have. You did log to the base 2 of x. Remember? Well, this is log to the base e of x. Tell me what values of x you can never have. Go to your calculator and put log of 5. But you put log of -1 and you get undefined. So, but x has to be positive. Therefore, x is 5. Now, look, I will be doing the log curves next week. But just for now, that is a sketch of y equals log to the base e of x. We did sketch y equals log to the base 2 of x. E and 2 are very close. E is 2.7-ish. 2 is 2. We were sketching these last week or earlier this week. That's what a log curve looks like. So when you solve this, if you ever get a negative answer, you can't do the log of -1. It's not allowed. You can only do the log of a positive number. Okay? I'll do one more. Solve, and I'll do some more next week. ln of x plus 3 minus ln of x minus 1 equals ln 3. Look, I'll spend more time on these, okay? How am I going to combine those two? You've got to think of the log laws. Do you know which log law that is? ln. Well, this is the rules. These are the rules. Log to the base a of x plus log to the base a of y equals log to the base a of x times y. That's right. The other rule is log to the base a of x minus log to the base a of y is log to the base a of x divided by y. So that is in that form. So what do I do with these two? I divide them. You okay with that? So what you've done so far is written that in this form, but we haven't solved. But now just look at the left and the right. The log of that bracket equals the log of 3. That means that the bracket has to equal 3 because the log of that equals the log of that. So therefore, x plus 3 over x minus 1 has to equal 3. Yes? So what I'm trying to do is get both sides as log of something equals log of something. Once you've got log of that equals log of that, then obviously that bracket has to equal 3 because comparing the logs are the same. These are the same. They have to be the same. So now, x plus 3 equals 3 what? Bracket x minus 1. Expand. X plus 3 equals 3x minus 3. 3x minus x equals 6. Be careful. 2x equals 6, x equals 3. And if you put 3 in there and worked it out, you should get the same. We'll do more of these on next lesson. So that answer's fine. Just a few more examples of solving logarithmic equations, just continued from last lesson. Here's the first example. Solve, this is question 3. Solve log to the base 10 of x plus 4 minus log to the base 10 of x minus 5 equals 1. So we can, if you're doing the log of a number minus another one with the same base, remember this log law applies, where you're dividing the two, okay? So log to the base 10 of x plus 4 over x minus 5 equals 1. Now, we could do this now two ways. So one way that I could do it, I'm going to do this two ways, okay? I can do this using powers, and I can say base 10 to the power of 1 equals x plus 4 over x minus 5. Now, base 10 to the power of 1 is just 10, so I can just say, well, 10 times x minus 5 equals x plus 4. And I can solve the equation this way. So 10x minus 50 equals x plus 4. 10x minus x equals 4 plus 50. 9x is 54, and so x is 6. So that's one way to solve it. Or from there, I can say, well, log to the base 10 of x plus 4 over x minus 5 equals. Now I can write 1 as a log to the base 10, and I know that log to the base 10 of 10 is 1. Okay, so I'm rewriting the 1 as log to the base 10 of 10. So now I'm going to put this 10 here in brackets. So log to the base 10 of this bracket equals log to the base 10 of that bracket. That means that x plus 4 over x minus 5 equals 10. And so on. I can now solve as before, and I'll just get the same solution as before. So I get that 9x is 54, and so x is 6. So that's just two ways from, so obviously the first step is the same, you have to do the same thing, but here you can use indexes, all right, or powers to write this equation out, or here you can write 1, because we know that since log to the base 10 of 10 equals 1, all right, we use that to replace the 1 with that. Now, another equation down here, just this is the last one. Solve log to the base e of x minus 3 over log to the base e of x equals 2. Now, this sort of reminds you of the equations that look like this. Let's say x minus 3 over x equals 2. It's actually a quadratic, because what you do with this is multiply. So this is what you would have seen in the past, where you multiply through. So normally you would multiply through by x. So multiply each term by x. So you get x squared minus 3 equals 2x, and then you do x cubed minus 2x minus 3 equals 0, and then you factorize it and solve, etc. So we're going to use that idea with this. Okay? So what we're going to do here is multiply through by log to the base e of x. So I've got log to the base e of x squared. Now it's not just the x is squared, I'm squaring the whole thing, okay? Minus 3 times log to, so if I times this by log to the base e of x, they cancel, equals 2 log to the base e of x. Now I'm going to take everything over to the left. So I've got log to the base e of x all squared minus 2 log to the base e of x minus 3 equals 0. And so I'm just going to just do this by substitution. I'm just going to write let y equal log to the base e of x. So really I've just got y squared minus 2y minus 3 is 0. I mean, you can do that. You don't have to, but it's just instead of writing log to the base e of x out every time. So factorising this out, I've got two numbers that multiply to give negative 3 but add up to give 1 would be negative 3, sorry, but add up to give negative 2 would be negative 3 and 1. So solving that, I get y minus 3 is 0, so I get y equals 3 or y equals negative 1. but y equals log to the base e of x. So log to the base e of x is 3, or log to the base e of x is -1. Okay, now we need to solve for x. Now I could take, remember e is the base, so I've got e to the power of 3 equals x, so therefore x is e to the power of 3. Or for this one, e to the power of -1 is x, so e is the base. E to the power of -1 is x, so x is e to the -1 or 1 on e. And they are my two solutions for x. So therefore x equals e to the power of 3 or 1 on e. Okay? And if you want, you can check and see if that works. So checking, we've got log to the base e. I'm going to check for x is e cubed, for example. Log to the base e, the question is up here. Log to the base e of e cubed to -3 over log to the base e of e cubed. Let's see what that equals. Well, that is equal to 3 log to the base e of e -3 over 3 log to the base e of e. Sorry, just going off the page. Which is 3 times 1, which is 3, minus 3 over 3 times 1, which is 3 minus 3 on 3 is 1. So it's 3 minus 1, which is 2, which is correct, because we're trying to prove that. Okay, so substituting x is e cubed gives us that. And look, you can check the other one if you want. If x is 1 on e, we get log to the base e of 1 on e -3 over log to the base e of 1 on e. And what does that equal? Now log to the base e of 1 on e, that's e to the -1, so that becomes negative log to the base e of e -3 over negative log to the base e of e. Now that's -1 minus 3 over -1. So that's -1 plus 3, which is 2. That looks right as well. So both those solutions are correct. Okay.